In this video, we're going to be calculating the initial velocity of a truck that decelerates at a rate of negative 10 meters per second squared and comes to a complete stop in a distance of 35 meters. So the first thing you have to do to successfully solve a physics problem is go ahead and write a list of given information. So we have the constant acceleration of the truck, which is negative 10 meters per second squared. We have the delta x, the displacement of the truck, which is 35 meters. And we're looking for the initial velocity. But we also know that the final velocity of the truck is 0 because the truck comes to a complete stop. So if we draw a quick sketch of the situation, we've got our truck traveling with some unknown initial velocity. And in a distance of 35 meters, the truck will come to a complete stop. So a final velocity of 0 meters per second sometime in the future. And with an acceleration of negative 10 meters per second squared, we're asked to calculate what the initial velocity of the truck was. Now, one trick that you can use to figure out which one of the three kinematics equations is going to work in this scenario is to go ahead and write all three kinematics equations down on a piece of paper. Now that we've done that, what we can do is we can use the process of elimination to figure out which one of these equations will work. For example, v final is a variable that we have in our given list, so we're going to go ahead and put a check mark there. V initial is a variable that we do not have in our given list, so we're going to put an x there. Acceleration is a variable that we do have, and time is a variable that we do not have. We do not know how long it takes the car to stop. So that's two unknowns in one equation. That means that we're not going to be able to use that equation to calculate our initial velocity because we have time as an unknown. So we have two unknowns in that equation. Let's go to the second one. So delta x is something that we know. Acceleration, we know that. Time, we do not. Initial velocity, we do not. So we have the same problem. We have two unknowns in an equation, which means we're not going to be able to use that one. Now let's look at the final equation. So v final is something we have. V initial is also, we do not have that one. Acceleration, we do have, and delta x, we do have. Notice that there's only one x in that equation, one unknown, which means we're going to be able to use that equation, and that unknown happens to be the variable we're looking for. So that works out. So v final is 0, so 0 squared is just still 0. V initial squared plus 2 times. Now keep in mind that the acceleration is negative, and you have to plug it in as a negative in your equation. So negative 10 meters per second squared, and then times delta x, which is 35 meters. So we can go ahead and solve this. So 0 equals v naught squared minus 700. And we could leave the units until the end. So we can add 700 to both sides. So we have 700 is equal to v naught squared. And then if we take the square root of both sides, we have v naught is equal to 26.5 meters per second. Now we took the principal square root, or the positive square root, because v naught is a magnitude. So we don't include the negative square root there.